Okay, problem solved, which was quite stupid. And it was the fact that here there was a typing mistake. In particular, I wrote this one, and I was calling the function. That's why it was output the function here. What I really want actually is the cumulative deaths per region here, which is a data frame. Now, in fact, if I load the test, I get this output. Region, which are our columns, are Abruzzo, Basilicata, Calabria, etc., etc., until Veneto, 20 regions. And the index are the data, one date per row, and here we have the cumulative daily deaths, the cumulative daily deaths for, in fact, here we have, for example, for Veneto, 11,000 deaths. Now, remember the 24th of February. If I compute here the daily deaths with only this set of data, it means that I have to compute the difference between this and this. So here, this the first row becomes a row of nones here, and this is equal to 0, this is equal to 2, and so on. But actually here another line is intended, the 23 of February, in which we have only 0 cumulative deaths, the starting point. That's where the fake row takes place. In fact, if I run here, let me clear the output, rerun this test something, you will see that the data will still be from the 24th of February. And the delta here, for example, in Veneto is 1 death, as it should. We have 470 rows and 20 columns. Perfect. Another thing that we must do is to flatten the data frame. The function is the method is pretty stupid, and to be honest, we already seen it, so I just copy paste. We make use of this incremental deaths per region in order to aggregate by row and to store the data inside this df variable. We return df. In fact, here you can see, let me clear, you can see the output that is absolutely correct. Okay, we are finally able to compute the daily deaths from the cumulative deaths that we retrieve from the internet. Finally, we have to compute the normalize. We have to normalize the data. So here, excuse me, this should be commented. We write a new function which is called from deaths to deaths per million. Takes as arguments the configuration and the data. We'll see why it also takes the configuration. Because in order to compute the deaths or the deaths per million, we need the Italian population per region, which is this data stored in this data folder. So here we basically do the same thing. We compose the file name, would be string, the config dot input path slash the name is Italian population per region, excuse me, and is in CSV format. Then we will try. We will, as in the we have done for the following function, we do a try and an accept. Try will be Italian population, would be the name of the variable that contains this data. File name. Okay. Accept, return none. Same standard as before. We have to do also another thing. Here, the data reports the region, the year, and the population, while the data here has a date time as column. So I have to compute the year separately in order to be able to merge the two data frames. So I compute data here, a new column, which will be data.date, data.year. Okay. And finally, data would be also the new data frame that is equal to data.merge Italian population by region and also by year. That's where we discard the 2021 year, because we are doing an inner join, and the Italian population we have years from 2012 to 2020. Now we did just add the population to the data, to the original data frame. We can compute the deaths per million. That is equal to 1,000,000 times data deaths divided by data population, and I want to round everything with two digits after the point, 2 decimals. Finally, I want to select only the useful columns. Here, which columns do I have? Here I have date, I have year, I have region, I have deaths, and the deaths per million. Right? But since when I call this function, I want only data, region, and deaths per million. So the final table columns are date, region, and deaths per million. Nothing more. So we discard the year and the deaths right now. And here the comment will be select only useful columns. We can then drop all the other columns just by typing data.drop columns equal to data.columns.difference final table columns. So here I'm making the difference between all the columns and I subtract these three columns. And then what I get is the columns that I want to drop. I want to drop in place. I finally return data. Perfect. Perfect, but there's a problem. Because this function may be called after the download. So here, am I always sure that that's in this from cumulative to daily deaths function, the actual values here are deaths and not deaths per million? Well, I can fix this problem just by, if I repeat just to make it clear, more clear. First thing I will, when running the web app, the first function I will run will be download COVID data. We will see next that in order to code the web app in a very simple manner, we will need to run this function before this one. So we will have to normalize the deaths per million, the cumulative deaths to cumulative deaths per million, and then compute the actually daily deaths. Because of this, here the column for which we are aggregating maybe will not be deaths, but could also be deaths per million. In order to fix this problem, we just have to introduce another variable, the y column. Y column will be equal to the first result when scanning all the columns, for which the name of the column contains the word deaths. So when I compute the standard deaths, the column is actually named deaths. But when I compute first the deaths per million, well, the string deaths per million contains deaths. So I'm able to grab the y column. And also here I have to substitute the y column in here and also in here. Perfect. We could also build a tests for each of these changes, but we will not. The only thing we will do is to test the some sort of fake daily deaths here. I'll show you what I've done. I've created some fake daily deaths with this fake configuration, the data that I actually do not use. Here, in order to test the cumulative daily deaths, what I've done, I've created a fake data frame with the date 10 periods from the January 1st 2020 with a generic region with generic deaths, and then I computed the cumulative daily deaths. That's it. Okay, we have finally encoded the loader. Let's look at now at what we can do in our app. In our app we can finally import the three functions here: download COVID data, cumulative to COVID data, to daily deaths, and from deaths to deaths per million. We import these three functions, and we also, now that we import and manipulate data, we define the cumulative COVID daily deaths will be the result of download COVID data using the configuration. Then we have the COVID data daily deaths will be the cumulative daily deaths. About what? Cum COVID daily deaths. That's it. We have the data now. Let's finally use Streamlit to build the web app. So if in the loader we have stored the function that enable us to download and manipulate the data, now we can create another file named views, where we store the different components that build the actual web app. So let's import Streamlit finally as st, and for example let's introduce the main title. So def main title will be the dashboard title, and can be written as st.title COVID-19 deaths analysis. This is the main title. Then here I have created a simple decorator called add main title here, in which I pass the function for which I want to add the title, and I run the main title and then the view. This is just a wrapper. Then we will see how to use it next. Then I created the navbar. Here I just copy paste since it's quite easy, the code, but we will read it together. So the first thing to do is I want to create a navbar that Streamlit calls sidebar. So st.sidebar title. The title of the sidebar will be navigation bar. When calling the first element of a sidebar, automatically Streamlit creates the sidebar. Then I want to, let me show you here. I want to create this. Select one of the two dots here. These components are called radio in Streamlit. So the title of this box will be select one, and the two options are cumulative depth and daily depth. The default of the two options when first running the app will be the one with index equal to 0. So when running the app, the selected radio would be cumulative depth. Then we add a checkbox, normalize depth. Usually the predefined value is true, so the box is checked. Finally, I want to, as I can show you here, so we added the checkbox, and finally I want to add the picture. In order to add the picture, I have to import the picture in bytes. This means that I have to create an HTML, the tag with the tag image, the source would be data image png based with here base 64 and the bytes of the image. So I have to transform the image to bytes. This is a function that I've personally created, and we will see how to retrieve this one in a minute. Finally, I create a I post this HTML as a markdown, and I allow the HTML. Running HTML in this way for Streamlit is unsafe, but since I know what I'm doing here, we can run carefully the HTML. Finally, I return the view and then normalize. Why? Because in the app, in the display page, I need to know what I selected in the checkbox and in the radio. Did I select it to view the cumulative depth or the daily depth? Did I select it to show the normalized depth? This would be a string equal to cumulative depth or daily depth. This would be a boolean equals to true or false. Let's look at the to image to byte function. Image to bytes is a generic function that has no context actually in the app. It's a utility, and that's why we will create a new Python file where we will store the utilities function. And in fact, the utility functions will be actually this one. I import base64, which is a standard Python library. I write this this function that takes a path, reads bytes, and it encodes the bytes of the image in base 64 and returns the encoded. Finally, here I have to import the function as here from app hotels import image to bytes. Okay. So right now here I can write the navbar. So here the navbar will be view normalize is equal to navbar. And where does it came from? It comes from views. It will be, I just prefer to type it like this, because we will import also other functions in the views file. Okay, now we have display page. We have two pages actually. The one if view is equal to cumulative depths, and the one I prefer to do something like this in order to show you actually what is daily. We will do something. What we will do here? Well, actually we will plot the data. Here we will plot cumulative data, and here instead we will plot daily data. Let's create then the views. Let me go back then with the views. Here the navbar, and finally we create the first view, the cumulative one. So cumulative daily depths view will take the data and will print an header named cumulative daily depths, so we know what we are doing. And then we will plot the chart. So here we can use the Streamlit function Altair chart that will automatically add the chart to the HTML page. But it would be quite a mess to write all the Altair code to display the Altair chart, right? And the views file is, in my opinion, not the correct place where to run all the code about the chart. So here, let's pause it for a minute. Also here we want to add the main title, so we call the add main title decorator. Second, we will add the main title to this one too. We have def daily depths view data. In here we will use also the config. See in a minute why. We have an header, a Streamlit header named daily depths. And if you remember, so let me show you what we are writing here. Basically, in the cumulative, the main title that we attached using the decorator is this one. Then the header is the cumulative daily depths, and then we print the Altair library, the Altair plot. In daily depths, there's another component, the title that we add using the decorator, the header, and then this component, which is a select, is named select box in Streamlit. So we have a select box, we select the image, and then we have the usual Altair plot. Going back to code then, here we have to create the selected region. Would be the result of what? A select box a Streamlit select box named regions, titled regions, that will have as possible values config.regions. That's where config is needed, right? Finally, Streamlit Altair chart, and we will plot the chart, okay? Now we have to finally code the two Altair charts. We create another file that we will name plots.py, and here I will just copy paste the code we have written in the previous course. So the line plot cumulative daily deaths is the one referring to cumulative deaths, and requests only the data. The line plot daily deaths instead refers of course to the daily deaths page, requires data but also the region for which I have to and for which I want to plot things. Here you can see the mechanism again taking place for the deaths or deaths per million. Okay. Right now then we just write these two names in the view. So here we have the line plot daily deaths that requires we can import. You can see here automatically imports the line plot daily deaths, but also I want to import the line plot cumulative daily deaths, and I will use the line plot cumulative daily deaths in the cumulative view. Quite nice, right? Here let's forget about for a minute about the normalize, and let's look at this. Here we will need to import the views, right? Other views with the cumulative daily deaths views and the daily deaths view. Here we have we will plot the cumulative daily deaths views that requires only the data. Let's forget for a minute about the COVID, the normalization. Let's use only this. And here we use the daily deaths view, and we have to pass the configuration, and let me see if I remember correctly. Looking at views, the daily deaths, what exactly? The configuration and the data. So I have to pass here the config and also the COVID daily deaths, right? That's it. Let's try to run this this application by typing streamlit run and finally run.py. Let's look, let's see if everything works. Okay, you can see this is the local URL and this is the output. It's loading. We have the cumulative. Let's see. All right, everything is working so far. Of course, the normalized depth doesn't change anything. You see it running, but doesn't change anything because, of course, we have not implemented yet this functionality. Everything is working here, and let's see with the daily depth. Okay, it's working also here. Perfect. Great. So let's close this. Let's go back to the Visual Studio Code. Let's complete our app by doing two things. First, we have to implement the normalization. So views is done here. Run is done. Init needs to be changed. Utils data loader is done. Config is done. Okay. Let's include the normalization functionality. We can add the normalization functionality calling from the loader file the from depth to depth per million function. So here, instead of passing directly the data frame, we tell you use from the result of this function if normalize is true, else you use cumulative COVID deaths. We do the same thing, but for here it requires also the configuration. We have to remember also about it, otherwise you cannot retrieve the Italian population per region. We do the same thing here, but for what? So this goes there. Oopsie. Okay, but we are using the COVID daily deaths here. Let's run. Let's close this one. Stop. Let's run again the application and see if the functionalities now are working. Okay, these are the cumulative normalized. In fact, you can see that Lombardia here is overcame by Valle d'Aosta, right? We deselect the checkbox and we should get okay. The same for daily deaths. Okay, here we have the cumulative and here we have the normalized, right? Okay, perfect. The same as the original, if you remember. Let me see. This is wrong. Okay, let's adjust here by because we are passing by mistake. We are passing here the cumulative instead. We have to pass the incremental. Okay, we are making a change to the code and the application, you can see source file change, rerun the application, and here we go. It works the same. Perfect. Now we have to do only one other thing, the logging part. Now the application seems to run correctly. The main issue would be the data acquisition and manipulation. So why not logging this process? And when something may go wrong, we have the log on where and when the code broke. So let's close here let me show you here. Here you can see that I want to show you the fact that everything works now, okay? When you change the code, for example, here, excuse me, here I add here you can see that it tells you source file changed, and you can rerun the app. Okay, let's stop the app for now and go back to our Visual Studio Code, and let's implement the logging part. We will use the Python library named logging, and we will need to create a logger in order to be able to log everything as we want. For example, we want to log in the console, but also to store the logging on a file. Let's create the logger first, and then we implement the logging function in our code, the one that we have already written. So logging logger.py. We import logging, and we want to create a logger. I personally prefer to create a class named root logger manager that will handle everything. In particular, I like to use different format in the logging for the console and for the logs stored on the computer. That's why I predefined these three formats. The level name, you have to know that when logging you have several level names. How critical is the log, the event that you are logging? For example, it may be a warning, an error, a fatal error, just a debug log, an info log, and so on. So here, for example, in the basic formatter, I type the time, the level of the log, and the message, the message that I write. Here I add more: the time, the module, where the function, the code is comes from, so one of these files, the function from which the login comes from, the level, and the message. There are several things. So when I want to initialize the root logger manager by creating a logger, a self logger, which will be logging dot get logger. Get the root logger. Here I've also provided some comments. Login get logger returns a reference to a logger instance with the specified name, if it is provided, or root if not. So here I'm getting the root logger. Second, I define the logging level. So self logger set level to login info. So the maximum logging level. If, for example, I set to debug, the info level would not be displayed. Finally, I remove attached to each logger there are several handlers. The console handlers that logs in the console, the file handler that logs on a file, and so on. Since I'm defining here a new logger, I have to remove the handlers that may be already written in the root logger. And here is my comment, for example. Why I do so? I remove handlers because other libraries may already define some of them. For example, Streamlit, Request, and so on already by default define custom handlers for their functionalities, and they also have custom formats in their logins. If I do not remove the handlers, I would get a mix of logs from my package and from other libraries, also with different formats. It would be a mess. That's why here I remove the handlers. Then I just copy-paste the other methods here. The code here I've created. Excuse me a minute. We have also to add these three libraries: the datetime, the pathlib, and the typing optional. So here we call this function configure, where we add this optional argument, the output path. The optional argument because if I want the console login is set up by default using this basic formatter. If the output path is specified, then I also log into a file using this output path and this verbose formatter. Set console login. Here the console login is named stream handler, and then I simply define the formatter, the level, and then I add the handler to the logger. I do the same for the file logging, except for the fact that I also create the log folder and the log file using the pathlib library. Particular here, I create the file name as the path, the specified path, and the name of the path will be year, month, day, dash, hour, minute, second, dot log. I try to create the directories until I create completely this path, if possible, if I'm authorized to create directories in this folder. And then I check, make sure that the file now exists, because file handler should create this file. Here, for example, if something is wrong, I already logged something, unable to create the file in order to store the output logs, and then I output the type of error. Finally, I set the login format and I add the handler to the logger. Okay, I've created this class. Now I use the logger manager. I define the logger manager as the root logger manager. Logger manager, I type configure, and I will use the path logs. So logs would be the directory in which I will store all my logs. And finally, I just for simplicity, I will rename the logger as logger equal to logger manager.logger. That's it. I've created my logger. Let's now make use of this. In particular, in the loader file. Let's start with the download COVID data. I have to import the logger. So here, from app.logger import logger. In download COVID data, I want to log what is happening when I make the GET request. So for example, here I can add an info. If everything goes fine here, excuse me, oops. If everything goes fine, here I log an info in which I tell successfully loaded the COVID-19 cumulative deaths from the URL. If something breaks, instead, I log the fact that unable to find or download the COVID-19 cumulative deaths dataset at this URL, and so on. I can do a lot of things. Another thing that I want to do here is to check whether there are problems with the data, and if there are some, I want to log what's wrong. The checks that I can do, one example of a check would be inside the cumulative to daily deaths function. In fact, I expect that the daily deaths should be equal or greater than 0. But since they are a result of a computation, this is not obvious. That's why we could add a check. Okay. I just simply copy paste the code so we can read together what it means. So search, here I've computed the incremental depths per region. Remember, it's a table in which the index are the dates, and we have 20 columns, one for each region. How do I get the errors? How I want to present these errors? Well, I want to present a dictionary in which the key is the region and the value is the number of errors. How can I do it? Well, regions, for each region in regions, this means for each column in this data frame, what do? I select the column referring to this region and I check if there are some values less than 0. So I will get a column with the values true or false. Remember that Python encodes false as value 0 and true as value 1. If I sum everything, then this means that if I sum everything and I get a value greater than 0, it means that I have some problems, some errors inside this specific column. So I include the region as key and values as the number of errors, of course only if there are some errors. If this dictionary presents at least one region with some errors, I log a warning where I tell find some inconsistent data with negative daily depths, and then I print the dictionary. Okay, I don't want to tell you to code with you the other login that can be made. I just wanted to focus on this specific concept about the logging errors, and now I just copy paste the other logging parts from my notes. For example, here we have successfully prepared, etc., etc. In order to see the logging work, let's rerun the Streamlit app by typing streamlit run.py. We run, okay, it's working. Let's look at it. Info, successfully loaded the COVID-19 cumulative deaths dataset from this link. Okay. Second log, successfully prepared the COVID-19 cumulative daily deaths with shape. It also tells you the shape. 9,400 rows and 3 columns. Warning, found some inconsistent data with negative daily deaths. We have Abruzzo with 1 error, Calabria with 1 error, Marche with 3 errors, Sardinia with 1, Trentino Alto Adige with 2, Valle d'Aosta with 1 and Veneto with 1. Then it tells me, successfully prepared the COVID-19 daily deaths dataset with shape, okay, the same. Successfully load the Italian population, successfully prepared the Italian population dataset. We can see also, this is the login inside the console, and here we have the file that logs everything. Let's view this way. That shows me everything in much more detail, since I have the verb for the file login, I've selected the verbose formatter. In fact, here I have the date, the date time, the module. I am in the loader.py file. The function is download COVID data, and then I have the level, the info, and the message, and so on. You see loader cumulative to daily deaths, and here loader from deaths to deaths per million. Of course, here let me open up. The app works as before, as you can see here. Works correctly as before. Daily deaths, for example, for Trentino Alto Adige, we have seen that 2 errors have been noticed. Here is the most relevant one. Normalize deaths we have, okay, and so on. That's it. We have finally implemented a completely running web app, a prototype of web app, and we also studied how to implement login and unit testing in Python inside this web app. So this was the heaviest module about this Python introductory course series. In the next one, instead, we will take a look at how to manipulate images using Python. Take care and see you in the next course. Bye.